This is a video to explain the domain and range of a function which is used in calculus in both class 11 and 12 mathematics. If f is a function from a to b, domain is the set of all elements x where x belongs to a, and range is the set of all elements fx where x belongs to a. So domain is the set of values which x takes, and range is the set of values which fx takes. We start with the question, find the domain and range of fx equal to root x plus 2. Now x plus 2 is always greater than or equal to 0 since we are dealing with real numbers. So x is greater than or equal to minus 2, and your domain would be the closed interval minus 2 to infinity. And the value of fx can never be negative because it's a square root of a positive real number, so range will be the closed interval 0 to infinity. Question 2. Fx equal to 1 by root x minus 5. Here x minus 5 being in the denominator, it is greater than 0. So x is greater than 5. So because we have a strict inequality, your domain is the open interval 5 to infinity. And range would be the open interval 0 to infinity. Since we cannot have 0 in the denominator, if we have 0, then you get 1 equal to 0. So range would be the open interval 0 to infinity. Question 3. Fx equal to x squared minus 9 by x minus 3. Here your domain is r minus 3 because x minus 3 cannot be equal to 0. So if we were to factorize x squared minus 9 as x plus 3 into x minus 3, your fx would be x plus 3. Since x not equal to 3, fx cannot be equal to 6. So your range is r minus 6. Question 4. Fx equal to x plus 1 by 2x plus 1. So to find the domain, the denominator 2x plus 1 cannot be equal to 0. So x cannot be equal to minus half. So your domain is r minus minus half. To find the range, let y equal to x plus 1 by 2x plus 1. So cross multiplying, you get 2xy plus y equal to x plus 1. Take the terms in x to one side. So I get x into 2y minus 1 is 1 minus y. So x is 1 minus y by 2y minus 1. Now this is defined when y not equal to minus half. Sorry, when y not equal to half. Because 2y minus 1 not equal to 0 means y not equal to half. So the values which fx can take would be r minus half. So your range is r minus half. Next, fx equal to square root of x squared minus 9. Again, x squared minus 9 is greater than or equal to 0. So we have x plus 3 into x minus 3 greater than or equal to 0 when you factorize. And the roots are minus 3 and 3. So we divide them into intervals on the number line and take intervals and we mark alternatively plus and minus starting with the rightmost interval. Now it is greater than or equal to 0 when it is to the right of 3 and to the left of minus 3. And because we have greater than or equal to sign, your domain would be the interval minus infinity to minus 3, including minus 3 union 3 to infinity including 3. Again going back to the range would be the closed interval 0 to infinity, closed at 0 and open at infinity. Next, fx equal to root 16 minus x squared. So 16 minus x squared greater than or equal to 0. We want positive coefficient of x squared, so multiplying by minus 1, we get x squared minus 16 less than or equal to 0, or x plus 4 into x minus 4 less than or equal to 0. So the roots are minus 4 and 4. Again, if we factorize and divide it into intervals and mark with alternate plus and minus, starting from the rightmost interval, it is negative between minus 4 to 4. And because we have the less than or equal to sign, we include minus 4 and 4. So your domain would be the closed interval minus 4 to 4. Now for x belonging to the closed interval minus 4 to 4, your values of fx will be between 0 to 4. So fx would belong to the closed interval 0 to 4. We can actually substitute values of x and see that the values of fx would lie between the closed interval 0 to 4. So your range is the closed interval 0 to 4. Coming to the next question, fx equal to 1 by root 4 minus x squared. Here 4 minus x squared being the denominator, it is greater than 0. We cannot have it as equal to 0. Again, we need the positive coefficient of x squared. So x squared minus 4 less than 0. Factorizing, you get x plus 2 into x minus 2 less than 0. So the roots would be minus 2 and 2. Again, considering the number line and dividing it to intervals and marking alternate plus and minus starting from the rightmost interval, it is negative between minus 2 to 2. And because we have the strict inequality, your domain would be the open interval minus 2 to 2. Now to find the range, it is not possible to find it directly. So we put y equal to 1 by root 4 minus x squared. So try to express x as a function of y. So root 4 minus x squared is 1 by y. Squaring, you get 4 minus x squared is 1 by y squared, or 4 minus 1 by y squared is x squared. Take the LCM, so 4y squared minus 1 by y squared equal to x squared. So we get x squared is 2y plus 1 into 2y minus 1 by y squared. So here the roots would be y equal to minus half and y equal to half. Again we divide it into intervals and mark alternate plus and minus starting from the rightmost interval, and we need it to be greater than or equal to 0 because it is a square. So it would be positive between minus infinity to minus half including minus half, and between half to infinity including half. But again going back, we are dealing with x squared. Square cannot be negative. So the roots would be just, the value of y would be just half to infinity. So the range would be the interval half to infinity, again including half because we have the equal to sign, greater than or equal to sign. So your range would be the semi-closed interval half to infinity.